What if I told you that yesterday, while you were scrolling through your phone, drinking your coffee, living your normal life, something happened in the Caribbean that shouldn't have been possible? Something that has scientists around the world frantically rewriting their models, their predictions, their understanding of what storms can actually do. Yesterday, October 28th, 2025, Jamaica was hit by a hurricane so impossibly powerful that it shattered a record that stood for 174 years. But here's what's keeping meteorologists awake at night. This wasn't just a strong storm. This was a storm that did something hurricanes aren't supposed to do. It broke the rules of physics as we understood them. And if you think this is just another disaster video, just another storm that came and went, you need to hear what happened in the 72 hours before Melissa made landfall. Because what transformed this system from a weak tropical disturbance into a Category 5 monster might be the most terrifying thing you'll hear all year. 3 days ago, meteorologists were tracking a weather system off the coast of Central America. Nothing special, nothing alarming, just another tropical disturbance in a region that sees dozens of them every hurricane season. Wind speeds were barely registering. The system was disorganized, weak, almost forgettable. Forecasters gave it a low probability of development. Some even thought it would dissipate entirely. But then something happened that made every meteorologist monitoring the Caribbean Sea stop what they were doing and stare at their screens in disbelief. Within less than 24 hours, the wind speeds doubled, then doubled again, then kept climbing. This wasn't normal intensification. This was rapid intensification on a scale that seemed almost supernatural. By the time the sun rose on October 27th, what had been a weak disturbance was now a Category 3 hurricane. By sunset, it was Category 5. 185-mile-per-hour winds, sustained, not gusts. Sustained winds that could peel the roof off a concrete building like it was made of paper. But here's the question nobody wants to answer. How does a storm gain that much power that quickly? What was feeding it? And more importantly, why did it happen now? The answer lies beneath the surface of the Caribbean Sea, and when you understand what's happening down there, you'll understand why Hurricane Melissa is not just a tragedy. It's a preview. The ocean temperatures in the Caribbean have been climbing for years, but this year they crossed a threshold that scientists had been dreading. The waters were not just warm. They were anomalously warm, several degrees above the historical average. And warm water to a hurricane is like gasoline to a fire. It doesn't just help the storm grow, it supercharges it. It turns a manageable system into an apocalyptic force of nature. Melissa drifted over a patch of ocean that was essentially a thermal battery, a reservoir of energy waiting to be unleashed. And unleashed it was. The storm began to feed. It pulled heat and moisture from the ocean surface, converting it into wind energy with ruthless efficiency. There was almost no wind shear to disrupt its structure. The upper atmosphere was perfectly aligned. High humidity levels created ideal conditions for cloud formation and rotation. Every single variable that could favor intensification was present. It was as if nature had assembled the perfect recipe for destruction, and Melissa devoured every advantage. Within hours, the storm's eye became sharply defined, a telltale sign of a mature and intensifying hurricane. The pressure in the center dropped precipitously, another ominous indicator. By the time emergency managers in Jamaica realized what they were facing, it was almost too late. Evacuation orders were issued, but there's only so much you can do when a Category 5 hurricane is bearing down on you with less than a day's notice. On the morning of October 28th, Hurricane Melissa slammed into Jamaica's northern coast with the force of a runaway freight train. 185-mile-per-hour winds. To put that in perspective, that's faster than most cars on a highway. Imagine that wind, that unrelenting, screaming wind, tearing through your neighborhood for hours. Not minutes, hours. Because here's where Melissa became truly diabolical. Unlike most hurricanes that race across land and move on, Melissa slowed down. It began to crawl. Some storms move at 15, 20 miles per hour. Melissa slowed to a near standstill, hovering over Jamaica like a predator toying with its prey. This meant that communities weren't just hit by hurricane-force winds. They were battered by them relentlessly, without pause, without mercy. The northern coast took the brunt of the initial impact. Montego Bay, a city known for its resorts and beaches, was transformed into a war zone. Windows exploded inward as the pressure differential became too great. Roofs were ripped away and hurled hundreds of feet. Palm trees that had stood for decades were snapped like toothpicks. The storm surge, a wall of ocean water pushed ashore by the wind, inundated coastal neighborhoods. Houses that had been someone's home just hours earlier were now underwater, their contents floating through the streets like debris in a river. The surge reached heights that exceeded even the worst-case scenarios. Entire blocks disappeared beneath the churning water. Boats were lifted from their moorings and deposited on rooftops. Cars floated away, crashing into buildings and each other. And then came the rain. Melissa didn't just bring wind. It brought a deluge. Torrential, unrelenting rainfall that didn't stop. Hour after hour, the skies opened up, dumping inches of rain every 60 minutes. The mountainous interior of Jamaica, with its steep slopes and narrow valleys, became a death trap. Rivers swelled beyond recognition. Streams that were normally knee-deep became raging torrents 30 feet wide. And then the landslides began. Entire hillsides gave way, sending thousands of tons of mud, rock, and debris cascading down into the valleys below. Roads were buried. Bridges were swept away. Entire communities found themselves cut off from the outside world, stranded in a landscape that had been fundamentally altered. By the time the sun set on October 28th, Jamaica was in the dark. Not just figuratively, literally. The national power grid had collapsed almost immediately. Over one-third of the island's electricity customers lost power within the first hours of the storm, and as the destruction continued, that number climbed higher. Communication lines went silent. Cell towers toppled. Internet infrastructure failed. For vast swaths of the island, there was no way to call for help, no way to reach loved ones, no way to know what was happening beyond your immediate surroundings. Emergency services were overwhelmed. Hospitals, some of which had sustained structural damage, were operating on backup generators that were running low on fuel. First responders couldn't reach many areas because the roads were impassable. Reports started trickling in from the few places that still had communication. Entire towns underwater, families trapped on rooftops, people missing. 6,000 people took refuge in temporary shelters, packed into schools and community centers that were never designed to hold that many bodies. 28,000 residents were under evacuation orders, but many couldn't leave. Either they had nowhere to go, or the roads out were already blocked. The scale of the disaster was becoming clear, and it was staggering. But as the winds finally began to ease in the early hours of October 29th, as Melissa weakened and drifted away, the people of Jamaica were left to confront a landscape that many didn't recognize anymore. Homes were gone, neighborhoods were destroyed, livelihoods were erased, and in the midst of that devastation, a question began to emerge. A question that goes far beyond Jamaica, far beyond this one storm. Why did this happen? And is this the new normal? Now, before we go any deeper into what Hurricane Melissa reveals about our future, I need your help. We're on a mission to reach 10,000 subscribers, and every single subscription helps us bring you more in-depth investigations like this one. If you're finding this video valuable, if you want to stay informed about the stories that matter, hit that subscribe button right now. And here's the thing, I want to hear from you. Drop a comment below and tell me, have you ever experienced a hurricane or extreme weather event? What was it like? How did you prepare? Let's build a community of people who are informed, aware, and ready for what's coming. Your voice matters. Your experience matters. So subscribe, comment, and let's keep this conversation going. Now, let's talk about what makes Hurricane Melissa so much more than just another storm. Because when scientists look at Melissa, they don't just see destruction. They see a pattern, a terrifying pattern that's been emerging over the last decade. Storms are intensifying faster, they're becoming stronger, and they're behaving in ways that our old models didn't predict. Melissa is a case study in rapid intensification, a phenomenon that's becoming disturbingly common. 20 years ago, a storm that intensified as quickly as Melissa would have been an extreme outlier. Today, it's starting to feel routine, and that should scare you, because rapid intensification means less warning time. It means less time to evacuate, less time to prepare, less time to save lives. When a storm goes from tropical disturbance to Category 5 in 72 hours, you don't have the luxury of a week-long preparation window. You have days, sometimes hours. But why is this happening? The answer is as simple as it is disturbing: climate change. And before you roll your eyes or think this is just another lecture, hear me out. Because the science here is not theoretical. It's observational, it's measurable, and it's undeniable. The Caribbean Sea has warmed significantly over the past decade. We're not talking about a fraction of a degree. We're talking about measurable, sustained increases in sea surface temperature. And those increases have consequences. Warm water is the fuel that powers hurricanes. The warmer the water, the more energy a storm can extract. It's basic thermodynamics. But it's not just about the water temperature. Rising sea levels, which are also driven by climate change, make storm surges more devastating. Coastal areas that used to be safe from flooding are now vulnerable. Communities that used to have natural buffers, like wetlands and mangroves, have lost those protections due to development and rising seas. And then there's the atmospheric component. Climate change is altering wind patterns, jet streams, and pressure systems. These changes can cause storms to move more slowly, which is exactly what happened with Melissa. A slow-moving hurricane is exponentially more destructive than a fast-moving one. It dumps more rain. It sustains hurricane-force winds for longer. It gives the storm surge more time to penetrate inland. Melissa's slow crawl over Jamaica wasn't bad luck. It was the result of atmospheric conditions that are becoming more common in a warming world. And here's the part that should keep you up at night. The models that predicted how often we'd see storms like Melissa were conservative. They underestimated how quickly things would change. Which means that what we're seeing now, these rapidly intensifying Category 5 monsters, might just be the beginning. Scientists who study hurricanes are frantically updating their research. They're looking at Melissa and storms like it, and realizing that the old assumptions don't hold anymore. What was once considered a once-in-a-century event is now happening multiple times per decade. The return periods for catastrophic storms are shrinking, and for small island nations like Jamaica, this is an existential threat. Because here's the brutal truth. Jamaica's infrastructure was not built for storms like Melissa. Most of the island's power lines, bridges, and coastal defenses were constructed decades ago, when Category 5 hurricanes were exceedingly rare in that region. The engineers who designed those systems couldn't have anticipated what we're dealing with now. And so when Melissa hit, everything failed. Not because people were negligent, but because the storm exceeded the design tolerances of virtually every system on the island. The roads, many of which snake through mountainous terrain, were buried under landslides. Major highways like the A1 and A3 became impassable, cutting off entire regions. The power grid, already fragile, crumbled under the assault. Communication infrastructure, which relies on towers and cables that can't withstand 185-mile-per-hour winds, went dark. And the economic toll is almost incomprehensible. Agriculture, which employs a significant portion of Jamaica's population, was devastated. Banana plantations, which take years to mature, were flattened in hours. Sugar cane fields were submerged. Livestock drowned. The losses run into the hundreds of millions of dollars, and that's just in agriculture. Tourism, the lifeblood of Jamaica's economy, came to a complete standstill. Airports closed, hotels flooded, beaches were buried under debris and contaminated with sewage and chemicals. The resorts that attract millions of visitors every year were transformed into disaster zones. Cruise ships that had been scheduled to dock diverted to other ports. The revenue stream that keeps the island's economy afloat was severed overnight. But the human cost transcends dollars and cents. 6,000 people in shelters, 28,000 under evacuation orders, families torn apart, children traumatized, people who lost everything they owned in the span of a few hours. The psychological toll of a disaster like this is profound and long-lasting. There's the immediate trauma of surviving the storm, the terror of hearing your house being torn apart around you, the helplessness of watching water rise and having nowhere to go. And then there's the aftermath, the grief of losing your home, the uncertainty of not knowing how you'll rebuild, the exhaustion of living in a shelter with no privacy, no routine, no sense of normalcy. For many Jamaicans, Hurricane Melissa wasn't just a weather event. It was a life-altering catastrophe that will shape their futures for years to come. And Jamaica is not alone. Across the Caribbean, across the Pacific, small island nations are facing an impossible reality. They contributed almost nothing to the climate crisis. Their carbon emissions are negligible, and yet they are on the front lines of its consequences. They are the ones paying the price for the industrialization of wealthier nations, the ones dealing with storms that are fueled by greenhouse gases they didn't emit. And the cruel irony is that these nations have the least resources to adapt. They can't afford to build storm-proof infrastructure. They can't relocate entire populations. They can't fund the kind of early warning systems and disaster preparedness programs that would save lives. They are trapped in a cycle of destruction and recovery that is becoming shorter and shorter. A hurricane hits, they rebuild. Another hurricane hits, they rebuild again. And each time it gets harder. The resources get thinner. The resilience wears down. Hurricane Melissa is not just a Jamaican story. It's a global story. It's a story about what happens when we ignore warnings, when we delay action, when we prioritize short-term economic interests over long-term survival. Because make no mistake, this is about survival. For islands like Jamaica, for coastal communities around the world, for anyone living in a hurricane-prone region, the question is not if another Melissa will come. It's when. And how much stronger will it be? The data is clear. Storms are getting stronger. They're intensifying faster. They're dumping more rain. They're moving more slowly. Every single trend is moving in the wrong direction. And if we don't act, if we don't make drastic changes to how we produce energy, how we build our communities, how we prepare for disasters, the future is going to be defined by events like Hurricane Melissa. So what can be done? On a global scale, the answer is clear. We need to reduce greenhouse gas emissions dramatically and immediately. We need to transition to renewable energy. We need to stop subsidizing fossil fuels and start investing in clean technology. We need international cooperation, not competition. Wealthy nations, the ones whose industrial revolutions kick-started this crisis, need to step up and provide financial and technical support to vulnerable regions. This isn't charity, it's responsibility. On a local level, communities need to invest in resilience. That means building infrastructure that can withstand extreme weather. It means creating robust early warning systems. It means developing evacuation plans that actually work. It means protecting natural buffers like mangroves and wetland that absorb storm surge and reduce flooding. It means educating populations about the risks they face and how to prepare. But here's the uncomfortable truth. Even if we do everything right starting today, we're still going to see more storms like Melissa. The warming that's already occurred has locked in a certain amount of climate change. The ocean temperatures aren't going to cool overnight. The sea levels aren't going to drop. We are committed to a future with more frequent and intense hurricanes. What we can control is how much worse it gets. We can choose to limit the damage. We can choose to adapt. We can choose to prepare. Or we can choose to ignore it and hope for the best. And hope, as Hurricane Melissa demonstrated, is not a strategy. The people of Jamaica are resilient. They've faced hurricanes before. They'll rebuild. They'll recover. But the question we all need to ask ourselves is, how many more times will they have to do this? How many more storms will it take before we wake up? Hurricane Melissa is a wake-up call. It's a glimpse into a future that's arriving faster than anyone predicted. It's a reminder that the climate crisis is not some distant threat. It's here. It's now. It's tearing through communities and upending lives. And if we don't change course, if we don't take bold action, Hurricane Melissa won't be remembered as the storm of the century. It'll be remembered as the storm that should have warned us. Because what comes next could be so much worse. The science is telling us that we're entering an era of mega storms. Hurricanes that push the boundaries of what we thought was possible. Category 5 storms that linger for days. Rainfall measured in feet, not inches. Storm surges that rewrite coastlines. This isn't science fiction. This is the trajectory we're on. And the only question that matters is whether we're going to do something about it or just watch it happen. So here's my challenge to you. Don't let Hurricane Melissa be just another headline. Don't let it fade from your memory in a week. Use it as a catalyst. Educate yourself about climate change. Support policies and politicians who take it seriously. Reduce your own carbon footprint. Have conversations with your family and friends. Because change happens when individuals decide that the status quo is unacceptable. It happens when people demand better from their leaders. It happens when we stop waiting for someone else to fix the problem and start taking action ourselves. Hurricane Melissa terrorized Jamaica, but it also revealed something important. It revealed that we're running out of time. It revealed that the warning scientists have been issuing for decades are coming true. And it revealed that the future is not set in stone. We still have a choice. We can still change the outcome, but we have to act now, not next year, not when it's more convenient. Now, what happened in Jamaica yesterday is a tragedy, but it doesn't have to be our future unless we let it.